Okay, I am on. I don't hear any difference. Oh, now I'm coming over the speakers. Ooh, okay. So, yeah, Rick's working on it. Okay, that's better. So these were the kind of the projects that students, and those were interesting because students could buy those, build them themselves in the tech lab, do some programming with the instructor, and then take them home, add more hardware, change the hardware, program them, do whatever they want, right? And that was cool, and that's still a lot of people interested. I think there are one person posting on the ETA robot site that is doing something similar, and he wants to be able to use ChatGPT, I think, to control his robot, something like that, right, Doug? So these have limited processing. This one has an Arduino controller. That one's probably the least processing. This one has a Raspberry Pi. Those are all kind of, think of them as really small computers. So limited resources compared to your desktops and laptops. But for a lot of things, certainly for controlling the sensors and whatnot, plenty of power. If you wanted to run like one of the local large language model, like ChatGPT locally, that would be tough to do with that kind of thing. So I said, so that was predated my coming here. I actually built a couple of these as well. In 2023, Keith gave a class on combat robots. We were doing class sessions with Hyla, the Hyla School. You know where that is, up by towards Linwood as you go there? Well, they came over to Barn and said, hey, we'd like to do some tech classes here or teach our students more STEM type classes. Could you build a curriculum for us? And so Doug and I and others in the tech lab put something together, and Keith did a session on combat robots. Keith is involved with the BattleBot. Keith is on his phone right there. So have you guys ever seen the BattleBots stuff? Yeah. They have it over in Seattle, and I think Keith participated in one. No, I didn't. I lost that from 11-year-old. Oh, damn it. If you weren't here, I would have given you credit for winning, Keith. But see, that was actually, for me, that was actually an interesting course to see engagement with students, because these were high school level students. Keith had them build the robots. Granted, they were kits, but there was some soldering involved, right? Yeah, they had to solder pieces and put their board. No, they think of it kind of like this, but they didn't have all this hardware on it, but they had like shovels. They had things that you would use in a combat, and they were remote controlled. They weren't autonomous, right? So every student had their own remote controller, and then they battled each other in an arena that Keith built as well. But the students really liked it. They enjoyed it very much. And I thought, ooh, you know, if you're going to teach something in robotics, teaching technology is not that exciting, right? Oh, I'm going to teach you how to use computer vision, which I did last year. And I got a handful of students, but you know, where do you go from there? And you know, teaching individual technology is not going to go over big. Whereas if you're going to build something and have them compete in a combat robot setting, that's far more interesting to a lot of people. So that was the end of last year. I went away to Austin because my wife and I are snowbirds. I took some classes at the University of Texas, robotics classes. I was curious. One professor there, Professor Justin Hart, really has a strong program. And he calls it human-robot interaction. He's trying to figure out how he makes robots so that they interact more naturally with people. And he's really got a huge engagement with the student body in the University of Texas. So I was really curious on how does he teach these courses? And I'm getting way ahead of my slides here. So I'm basically on how do we get here. So he came up with a platform he called Dobby. And we'll talk about this in a little bit here. Raspberry Pi, Arduino kits, combat robots. I'm still kind of in this, how did we get here? He has, the interesting thing about Professor Hart, he has 3 of these Dobby robots that he built. I have a video on one of the students giving a presentation. He taught the robot how to give a tour of the robot lab at University of Texas. kind of something simple. I thought, how interesting would this be? Students glommed onto that, and they wanted to add all kinds of things to it. They wanted to, first of all, they wanted the robot to give a tour of the entire University of Texas. That's the goal. And so, if you've ever been to a college campus, there's always one walkway where when in between classes, all of the students come out of their classes and it's a mob scene. And in the University of Texas, there are people on scooters, there are people on e-bikes, there are people running, and of course they're students, so they don't know how to drive, so there's no left, right. This is mostly walking, right? So it's just random chaos. I can remember I had to change classes. I was like, oh my God, I got to get across Speedway and figure out how to get to my next class and not get run over by a scooter or an e-bike as well. So one of the students said, I want to take the robot and program it to get through Speedway in what they call interclass time. And I was like, ooh. Me as a human, I struggle with doing that. And they wanted to do it in a polite way. Not just have the robot charge through and have all the people move out of the way. No, pause when you got up to a person, go around them and everything else. And so they didn't finish that while I was there. They're still working on it. But the idea is all the students came with different interests. There was one student that had a mother that was deaf, and he wanted to do sign language, teach the robot, and it had a display. It would show the sign language while it was actually talking to the other students. They all had different projects that they were working on and interests. Yeah, Doug. Yeah, well, I'll show it to you too. It is kind of interesting. Okay, so why a greeting robot? So this got me onto the robot. Hey, rather than teaching another robot technology class, like the computer vision class that I taught last year, what if we start building a platform for a greeting robot, an actual physical robot that's going to take people on a tour here at the barn. By the way, there are about 3 or 4 people that have this job at the barn today. You walk up to them, I think it's on Wednesday afternoons and Sundays. You can go up to the front desk and say, I want a tour. And they'll walk you around all the studios that we have here, the tech lab, the wood shop, the jewelry station, the kitchen, etc. So I said, okay, let's do this. And I started saying, okay, so what are the steps that we need to do to actually get a greeting robot up and running here at the barn? Obviously, you need a physical robot. I wanted something that wasn't complete. Like the one at Austin, it had no arms, right? It just rolled around and it had a Lenovo display like this as its only interface with humans as well. They could have done a lot better with that. I wanted it to be a little more personal than that. And eventually, I do want to add arms to this thing. Because even if you think about a tour, getting through doors, we have to fob into studios. If we get really great with this arm in the tech lab, I'd like to even kick off a 3D printing job while you're there and it's taking you on a tour, and hopefully that job finishes. So the idea is to start building a platform. And that comes with a lot of different technology. You start talking, it pulls in a lot of things. ROS2, by the way, that's Robot Operating System. It's an entire platform. I could give a couple of hour talk on that alone, because there's a lot to that. Simulators, which I'm going to show you one today. How to do object detection and avoidance. That's what that person was doing when it walked down Speedway. He was trying to detect where people were standing and how to avoid the people. People identification. You think about a robot, you think, just being able to recognize your face. When I'm talking to you, I look into your eyes. When you're talking to a robot, it's strange if he's talking to you and he's staring off into space, right? You want the eyes to track your eyes. It sounds trivial, right? That's not so trivial. That's one of the projects that University of Texas students have, because they're going to put a face on that display, and they want the eyes of that face, when I'm talking to Ray, to actually look at Ray's eyes. When I'm talking to Lisa, look at your eyes as well. So, interesting thing. And so, the thing I came away from at University of Texas, there was a wide range of skills. Even in here with the barn, everyone thinks, oh, this is a really techie thing. No, there's a lot of content things here. I was talking to Kate in our admin office, who's one of the persons that gives people a tour. And she says, boy, Nat, it would be great it's great you have a display with a person's face and he mouths the words, but it would be nice if they had a display where it shows all the things that people have 3D printed, or the process of something 3D printed in an accelerated video on another display on there. And I said, oh, so Kate, would you be interested in developing that content as well? So you can see there's even people that are not necessarily programmers, but are proficient at producing videos or content like that, there's a role to play here as well. So that's why I was trying to attract as many different people and see how many different skills we can get for people. Okay, so what are these greetings? There's a lot of these in industry right now, believe it or not. And there's some actually in airports. I have not run into the airports where there was a greeting robot. Has anyone in the room? There was one. You have, Keith? Okay. No, no, no. The hotel is one. I haven't been to a hotel with a greeting robot yet either. Yeah, yeah, yeah. Yeah, that's about the closest I've come to. Um, I have been to a restaurant. Yeah, I've been to a sushi restaurant in Porto, Portugal, where they had a robot. That one didn't talk. No, it served you food. It would it would take your order and it would serve you food, but it would not talk, which was kind of odd because it would bring you the food and yours would be on a certain level and it would blink and you just have to know, oh yeah, my food is on level 2 there.
Sounds like a charming dining experience.
So here are the different examples of breeding robots, and some of these get pretty, they get more human-like as well. You notice there are a lot more to this that go off the high end, and they're being developed by, like Tesla has one called Optimus that has legs. It can actually walk upstairs and all the other things. I'm trying to avoid the walking part. Maybe later when that technology becomes a little more affordable. But even here, I mean, you're starting with some of these, and they're in the, hundreds of dollars. To the top row there, you get into the thousands, and you get to the bottom, you get into the tens of thousands of dollars for one of these guys.
So will your robot have anything more sophisticated than any of these robots?
So the one I'm doing for version 1 is very similar to the first 2 or 3 there, where I'm going to have a platform, and I want something sturdy, because I want to build on this thing, and a monitor like that, and maybe 2 monitors. So it's going to look like probably one of those first 3 things. I say this, Ray, we haven't purchased any hardware yet, so this Doug and I and others are going to work on this and may change between now and when we actually purchase the hardware. Doug sent me one the first time there, and what was that one, $22,000 or something like that? Walking humanoid with, yeah, that was fairly expensive. So, just to give you the feel, I have some videos that hopefully the audio works here. I kept talking about this Texas one. Oh, I have this actually scrolled to the right place already. Let's see if this works.
Multi-step task execution with fluent, human-like conversation. Our framework consists of a single AI agent derived from GPT-4, which is responsible for both natural
people building robotics compete in to see who has the better technology. And you can imagine what Amazon wanted this to have robots that man their warehouses, right? And they wanted them to be able to go up and say, hey, I want to get the fuzzy red doll for Anne. Go find that doll, put it in the bin, and bring it up here so we can send it off. So they have a combination, basically, that has a bunch of cubicles with a bunch of objects in it. And the robot knew ahead what the objects were and knew how to grasp individual objects, but didn't know where they were going to be or where it had to put them. So they would come into the contest and it says, okay, I want you to get these 5 items, put 2 of them in this bin and 3 of them in this bin over here. And they were timed. How fast can you complete this task? So that was RoboCup. And then they came up with, and they said, that's interesting for industry and everything else. Then they came up with RoboCup at home, which is the one that Connor mentioned in there, and the one that Justin Hart's students are most interested in. And these are doing things in the home. Like they want to be able to say, a robot walks up to a front door of your house, and you're going to say, make me a cup of coffee, right? So it's got to figure out, a cup of coffee, got to find the kitchen, got to find coffee, got to find the coffee cup, got to find the coffee maker, got to make coffee. Yeah, sight unseen, never seen your house. So it's, yeah, this is where I come from. Connie, kids, everyone, I say, I want a robot. I can say, make me a drink, make me a gin and tonic. And it goes, figures that out, figures out what the gin is, figures out the tonic, glass, ice, you know, the whole thing, and brings it to me as well. That's my ultimate goal to get there. And I tell you, I was actually optimistic 2 years ago. I said, how long this can be. The University of Texas really kind of reset me. I took in this past term, there was a really great professor from Stanford that's really into robotic arms and manipulation. And I really got a sense for all the physics and math behind a robot grabbing a wine glass without crushing it or dropping it on the ground and bringing it up and carrying it somewhere without spilling it as well. You think, trivial, anything, certainly we're past that. That is not so trivial, even right down to the texture of the hand and how it feels that glass and make sure it's not going to crush it. People are still working on that problem, yes.
So quick question on the conversational robot. When the robot was speaking back to the customer,
Yeah.
that wasn't a pre-recorded message, was it?
It was. Yes, a lot of it is. And as a matter of fact, if I keep, so it was very, and you're going to see, I'm going to show you some of that on mine as well. Some of it was canned, okay, when it said, I want to learn about the RoboCup at home. Some of it was generated by the large language model. So if you ask a general question like, how is the University of Texas basketball team doing? It doesn't have pre-recorded, but it'll ask the large language model. It'll go up look for results and say, the UT women's basketball team is 4-8 and they won their last game. That, it all just got out of the large language model.
There is a device or a process for a computer to put together a unique response.
For some of the things in the lab, but for these other things that were generic about University of Texas, they had no canned audio. It was just, so this is how ChatGPT works. When you go up to it and say, tell me more about how the Mariners game yesterday, who hit the home runs and whatnot. It goes out, it finds it, it sorts it on the internet, but then it constructs the story itself. That's what Dobby was doing about the University of Texas. The interesting thing they had was making sure people didn't ask questions that didn't want answering. Keep it to the University of Texas, keep it to the robotics lab as well. Putting guardrails around it so it didn't start wandering. Okay, so let me show you a couple more here.
The ROS 2 navigation stack that comes on your TurtleBot 4. Now let's get started.
So
before we begin, if you're new to TurtleBot 4, make sure to check out our previous tutorial and we'll walk you through all the steps to get set up with your new robot. Otherwise, today we are using our TurtleBot 4 standard model as it's got this mounting platform. For which we've designed TurtleBot 4. Make sure to check out our previous tutorial and we'll walk you through all the steps to get set up with your new robot. Otherwise, today we are 3D printed a donut holder device that snaps right onto the top. And if you are looking for the design files for this, they will be linked in the description below. We've also got a computer that's running a Linux environment, as well as a package of a half dozen donuts from our favorite local donut shop, Lady Glaze. Now that our robot's turned on, we're going to go ahead and launch our SLAM toolbox, and we will do that by opening a new terminal and running this line of code. Now, SLAM will allow our robot to create a map as well as localize itself within a map at the same time. There's two different kinds of SLAM that are supported by the Turtlebot 4. There is synchronous and asynchronous SLAM. Today you'll notice we're using synchronous SLAM, and this will use a little bit more processing power, but it will help us to create a better quality map overall. Now, after we've launched SLAM, we're going to go ahead and open another new terminal and enter this line of code to launch RViz. And RViz is a program that will allow for us to view our robot as well as its location on our map when we're both generating the map and navigating today. Now we need to create a map of our environment for our Turtlebot 4 to navigate. To generate your map, you will need to place your Turtlebot on the ground and use your controller to drive it through your environment. You can monitor its completion by using RViz. Now, two important tips to consider is to clear out any objects in the area that are below the lidar of the Turtlebot, as it's a 2D sensor and therefore won't be able to see them. Also, just try not to have anyone walking around while you're mapping, as they could show up on your map.
Yep, it runs with the LiDAR and it'll map your thing out. And that's what she does before thing. And the interesting thing is you can see it building its map of the whole floor over here. She's going to come along later and label where everyone's office is. So that when she gets the command, the Turtlebot can take this donut.
Now the
to
robot
Rick's
is using the
office.
integrated
It'll,
2D
Rick's
LiDAR
office is
to
over
build
here.
the map.
I'm here.
The
I've got
LiDAR
to
is
navigate
scanning
through here
360
to get to
degrees
Rick's
and
office.
can detect objects up to a range of 12 meters. The red marks on the
I'll show you
RViz
one
map indicate the
robot
objects
delivery.
that the
This thing goes on
LiDAR
a
is
little longer.
currently
She
detecting.
delivers like 3 robots. Yep.
Now that our map has
It's
been
mapping
created, we
everything
will
right
save
now.
it by running
So,
the following line
LiDAR.
of code.
So maybe take
Once
a
the
little
map
moment
is
there.
saved, it will
So
generate
Connie
an
and I are
image
down in
file with
Austin,
this
and they
naming.
have the driverless cars down there. They've had them for 3 years or so, and they're all the Waymo ones there. And so when you look at them, they're Jaguars, nice cars, but they have this spinning thing right on the top, and actually they have 2 spinning things in the front as well. And those are the LiDAR. They're basically radar that senses where things are around them. Tesla is introducing driverless cars. He's not using LiDAR on any of those drivers. He's just using cameras. And there are some folks that say, you really need both. If one fails, you want to have a backup. And so we're going to see. So I'm curious to watch how the Tesla rollout goes to see.
Cameras can be integrated into the body.
Yeah.
And it's always good to give that file a check and make sure you covered all the areas you want to navigate. Also, a file with this naming convention is created, which we will reference when setting up our navigation in the next step. So now that we've saved our map, we can go ahead and create our donut delivery route. So we'll do this by launching the ROS nav2 stack using this line of code. And just note to replace the map name in this line with your map name you saved it with in the previous step. So the first donut we're going to be delivering today is to Trevor, our Turtlebot 4 builder. We'll get out our donuts. And load it on top of our Turtlebot. There. Awesome. So now we're going to open up RViz in a new terminal using this line of code. And at the top of the window, we're going to see 3 different buttons. The first button on the left side is called the 2D pose estimate, and we will use this to set the approximate initial location and orientation of our robot, or the pose of our robot. Next, we will click the nav2 goal button, and we will set our goal pose to the robot to be over by Trevor's desk. Once we click that, the nav2 stack will start right away and create a path towards your goal pose and navigate the robot over to the goal.
And then after that, the robot knew, okay, here I am. I'm pointed this way. It figured out this path to get to Trevor's office through here. Okay? So, all right, that's probably more than one. There's one more. So most of these you look at and they're like, wow, not very polished. This last one I have, and this is a company, Orion Star, and they're building these, and these get pretty expensive. But here, I'll show this one. I'll back it up right to the beginning. It may change. We're going to use one of those turtle bots that you saw in that video with Maddie. Mount on top of it a monitor stand, like one of these on the side. And the idea is put a face on this thing and have it, for the canned video, have it actually mouth the words and maybe even get some eye tracking down as well. I want this platform because if we decide to build something more sturdy, we could even consider adding, over time, arms, robotic arms and programming arms as well, right? But this would be a good base to start with, and we can learn a lot about the technology we need to actually do the greeting robot. We could mount it on that platform. We'd build other tubes around it, and by the way, 3D print them or whatever we need to do on that platform right there, right? So yes, we could do that. We haven't. That's probably not gonna. That's not gonna be in our first version because there's a lot. Building a robotic arm. The one thing I didn't really appreciate until the UT class is, an arm. Your arm has lots of degrees of freedom, right? Shoulder, elbow, wrist, every finger, and whatnot. And every one of those degrees of freedom adds another layer of complexity in both the math and the software to it. And so. Yes. Yeah. It could, and knocking things off tables and maybe hitting people and whatnot. So yeah, arms get into a whole nother level of programming, in some ways danger, than just something that goes around like a robot vacuum and bumps into walls and chairs. You know, okay, that's the way the first one was built, to actually bump things around. Okay, so here is kind of the face, and there's a bunch of these websites that you can go up to, enter in a bunch of text, and they will basically animate a face with that text, where they move their mouth and blink their eyes and all that kind of thing. And I've actually done that so I can get people more of a face. But that's probably what we'll put on, running on that monitor over there on the right that we mount on top of the TurtleBot. Okay? So that's kind of V1, my proposal here. So the technology pieces here. This is where things will start getting more technical. The ROS2, as I told you, is an operating system. And it introduces complexity. And I get asked the question a lot, well, why use it? Why not just not use ROS and just write everything in Python, you know? Well, so the reason they called it an operating system is because they wanted, the people that built this in, I think it was the University of California, is they wanted a platform. It's much like why you use Mac OS or Windows, right? Those operating systems have actually the ability to have drivers that work with any keyboard, any mouse, any speaker, anything else, right? So think of it, if you're a developer writing a program, you don't want to change your program for every different type of mouse or keyboard or speaker or camera or everything else that's out there. You want to write to one platform and then have it work. Someone plugs in a new camera you've never seen, should work. That's the idea with ROS, right? I'm going to write a program and I want to do, like Doug said, planning. I want it to avoid objects. I don't care if it's what LiDAR or what ultrasonic sensor it's using or whatever. I just want that data delivered from a platform in a standard way where I can write my code and be confident it works on whatever robot hardware it happens to be running. That's why we're using ROS. We want to write our program once and have it work with whatever hardware we end up swapping out of this platform, okay? And this is, the ROS 1 was the first version, I think it was back in 2015. I think ROS 2 came out right around COVID time, 2019, maybe a little before. And it's the one that's being used most widely now. They're busy working on, I'm sure, ROS 3, which will come out. And the platform has gotten better and better in each one of these releases. I'm sure ROS 3 will have more improvements with it as well. So with ROS, there is no simulator that comes with it. It's built to run the physical hardware. You run ROS on the TurtleBot and whatnot. So people realize they don't have a lot of money for this. So when you don't have money, what do? You run simulations instead. You run everything in software, right? And so there is a software package that runs with ROS called Gazebo. And that's, they think, oh, why don't you use that simulator? I toyed around with that for the last 2 years or so. It's a very capable simulator, but very complicated one. It actually you can program robotic arms with all the degrees of freedom. It knows a lot about physics, so that when you're picking something up heavy, your robot arm may not actually have the strength to pick it up. It has all of that capability, and it's 3D as well, right? If you're doing grasping of something, it's not good enough to have 2D. You have to understand 3D. So the interface to that is very complicated. This is not Gazebo. When I was in Austin, when they were doing this Dobby thing, I asked Connor, so are you going to probe this whole thing in Gazebo? Because I'm curious to see everything you're doing. He says, nah, I gave up on that. I said, first of all, I have a laptop that can't even run Gazebo. It only has 16 gig of RAM, and it's iCore 7. He said, can't run it. So he ended up, and he said, I only want to do 2D, and I basically just want to get the robot to navigate a 2D landscape. So Gazebo was way overkill. It doesn't even have an arm. I don't need all the other physics stuff that comes along with it. So he said, so I ended up using this simulator called PyRoboSim. It's a robot simulator written in Python that has a really simple interface. All the buttons on the top, that's all there is to it here as well. I'll show you this running on my machine, because this is actually my feeble attempt on recreating the tech lab layout. And some of the people in the room will kind of recognize it. And they'll say, not exactly accurate, Nat, particularly with size and everything else. But when you walk in the tech lab, and it's right where the 3 is, in mine, so there's no door, because I don't want the robot leaving, to tell you the truth. But there's I call that the dock, and that's actually where you sign in and where all the paper. This robot, the TurtleBot, is capable, when it's done giving the tour, to go to its charging station and recharge itself. So that's part of what I want. When it gives the tour, does it for 40 minutes. When it's done with that tour, it comes back to its dock, plugs itself in, and gets ready for the next thing. So that's why that's kind of called dock. We have a set of 3D printers that are roughly in that area in the tech lab. We have a bunch of desktops that are roughly in that area in the tech lab. Class area, there's a Mac, there's a Cricut that I'll talk about a little bit here. There's a soldering station. That next part of the lab is kind of where our laser lab is. And there's a soldering station in that corner of the room. There's an X tool, which is a high-powered laser cutter. And then we have 2 laser cutters, red and blue, that are down there as well. So that's kind of the rough layout. I'm using in this simulation the robot that came with PyRoboSim. This PyRoboSim was written by Sebastian Castro. He's kind of a name well known in robotics, and he's written kind of a lot of software on top of ROS. What I like he did with this, and the reason I chose it, is it runs all in Python, so you can run it locally, or you can change it so that it will actually generate the definition language for Gazebo, and it will load this whole thing into Gazebo. It can also run against ROS 2. So if you had a physical robot and you programmed everything with PyRoboSim, you could actually run your code against a physical robot. It works with ROS 2 as well. So that's cool, because that's eventually, when we get the physical robot, we're going to have to run with ROS 2, and make that robot move around and talk and do everything we want it to do. Okay, so I want to actually show you the simulator running here. So I have a setup here. And there's a lot of technology in here. This is more for software people that were going to do this. I was going to explain to them. I actually have this running on Linux. This is an Ubuntu ThinkPad, Lenovo ThinkPad. I actually have built it so that you can run this on Windows and, let's see if I can bring it up, and a Mac. But the best development platform, to tell you the truth, is running it on Linux because it has all the tools. And if you were software people, I'd go into why do we use Docker, a virtualization software. You know, if you were running on Windows, we actually use a Windows subsystem for Linux. I'm not planning on, but we still virtualize the Python environment. So there's some differences on these platforms that you have to do. But probably only a few handful people are interested in that. So let me skip to actually running the simulator. So let's see here. This is running under ROS 2. And so it brings up something that looks very similar to that slide that I showed you here, right? And there's our robot. And we can, this interface, you can randomize the pose where the robot starts at. Like it moved all the way over here. You can randomize its nav goal. Like I have class right here, so it chose the query goal. So if I click navigate, it's going to move from here over to the class station, if you will. It's going to build a path and whatnot. Now, you notice it doesn't take what looks like an optimal path here. So this is a planner. I told it, here's where the robot is, here's where the class is, and then it had to go figure out how do I get from where the robot is stationed, next to red over there, to class. And it's using a planner that is more, it's what I call greedy. It tries to find the first path it can. It doesn't try to find an optimal path. If it tried to find an optimal path, you see how it took that little hook out there? It probably would have smoothed that off and cut that off. So that's additional work that has to happen. We could do a better job on the planner.
So what would make it do that random detour?
Well, in this, it depends. When it's trying to find a path, it's doing this fan out. And you can see, it probably got to that first point and started fanning out. And these things are running on their own. And it said, oh, okay, I still can see the class. I can get there from this point. But it doesn't realize, but that's not the fastest point. And so in computer science, it's doing more depth first than breadth first. It's waiting for the first path, and that's the first path it finds. Yes. No, I used one of his. And I'm planning on changing it so it doesn't do random walks like that, which won't be that difficult to do. He did the basic stuff, and he expects other people to plug in their own planners. Correct. So I have another tour button in this here as well. You can see this is this tour button where it starts down at the dock. So it's going to find out how it gets back to the dock down here. And then we have this play button. So I have added a bunch of videos.
To the tech lab at the barn. My name is Barney. I am a greeting robot that can give you a tour. The tech lab is home base for a growing community of makers. You'll find equipment for 3D printing, laser cutting and etching, circuitry, robotics, drones, CNC programming, and coding. It's an ideal environment in which to experiment, create, and spur your imagination. Would you like to take a tour now?
So I've created videos for each one of those stations. You take the next step in the tour, it goes to the 3D printers, you can hit play again, and it'll start talking to you about 3D printers, right? So this is what would be running on that monitor that's mounted on top of the turtle body, right? And I'm gonna kill this now. So I've created videos for each one of those. That's fairly primitive. I pulled most of the content. I wrote most of it because I know the tech lab. I don't think I could do that for a lot of the other jewelry studio, fiber studio, and everything else. I'd have to have people do it. But it's kind of simple and not as exciting, right? And this is the same problem at University of Texas. First of all, we want a little bit more humor in this thing, make it a little more natural. And plus, for the tech lab, like when you're introducing a 3D printer, we want to show things that have been 3D printed. You may even want to show something being 3D printed as it's there, so that people say, I get used to this as well.
So what's the significance of the code on the right?
That's actually what's spitting out, and you see I have some audio overruns. That's an error message. But it's basically spitting out what it's trying to do. Right? If you lead through this navigating to class, remember when it went from its place? So that's the first thing. And then you keep reading through this. Take the next step in the tour, which is the dock. That's the first one. Take the next step in the tour, which is the 3D printers. So it's just printing out diagnostics.
What was the input to the sim? It looks like you've got Python script.
Oh, yeah. Yes, I hand-coded the Python script that talks to the PyRoboSim API. So that script, Doug, will work. It's running in ROS, by the way. So it's the robot is actually a ROS robot that's sending messages back to PyRoboSim. Now, you can run this locally just in Python, too. So I know this is probably something, Doug. So if I wanted to just run this Python 3 examples, barn, techlab.py, you'll see this will bring up the same kind of layout here. And now I'm not running with ROS. I'm just running on top of the PyRoboSim API. And I can do the same thing. I can take a tour here. So the idea is you can take the whole tour through this. Goes up to the 3D printers. It's basically going to go to all the stations, do a little blurb about them. Now, the idea is, that's the canned video thing that Ray asked about. The idea, this is going to be hooked up to a ChatGPT or some other large language model. And you'll be able to say, okay, you know, I understand what you said about 3D printers, but I want to print X. What filament type should I use? Right? There will be questions we don't have canned answers for. And it's going to do a search on the internet saying, okay, the person wants to build a whistle on this 3D printer. What's the ideal filament that they should use in the 3D printer? And hopefully answer that type of questions. So that's why at the end of each one of the videos, it says, any questions? And that's when the large language model will basically step in and say, okay, handle whatever questions you're going to get about the laser cutters or the 3D printers or the Cricut machines or whatever you want. Okay? So this whole talk, that's my simulator up and running right now. This whole talk was to engage other people in helping build this greeting robot. And like you think, oh, they're all programmers now. Not necessarily. I very much want content people that can come up with ways, these videos that we present, the canned videos at each one of the stations. And I'm very much engaging with the people who give the tours, because they've been doing this for a couple of years or so. And then also with each one of the studio people to say, how can we get people engaged? Like in the tech lab, I'd like the robot to be able to actually start a 3D printing job when he starts the tour, right? And then goes off and tours the other pieces, then comes back, something very simple, obviously, and says, oh, you know, here's your little badge that's been 3D printed. Or do it on a laser cutter. Like Doug cuts out metals for the jogging thing. That would be very much a thing we could kick off on the laser cutter, cut one metal, and then you could see it happening and then come away with something as well. I think you could do like one of those. I don't know if you could do like 5 of those at the same time. But this slide was all about the technology that I've gauged in so far. It's not the complete list. There's going to be a lot more on this list as well. And it's a little bit daunting, right? Because you look at it and say, wow, to write software on this thing, depending on what you want to do, I'll have to learn a lot about the platform. And so this is a tech talk. I'm open to actually giving classes on any one of the topics that people want to drill into these as well. What I've done for the last 2 months is build the platform. So when you build software now, to make sure that it's something that multiple developers can share writing code, as well as test and help deliver new pieces or add components to it, you want to start off with a solid base. So this is all in GitHub and uses Docker Hub and ROS and all those other things so that we can establish a platform and then have contributors from all around Bainbridge Island. I'd love to get the high school engaged in as well. And this, I think we're building a greeting robot for barn. If we build this platform right, people could pick this up and say, hey, I want that same thing, and I want it over in the BHS makerspace, or I want it in a library, or I want it somewhere else. That's way down the road, but this could be the same platform that they could use to build something like that.
So the platform is the bridging document that translates and unifies all these external programs towards a common goal, right?
Yes. Well, so that sounds more like ROS that combines all these different pieces into one thing.
Yeah.
But when we deliver this, like when you get, have you heard the term open source?
Yeah.
Okay, so we're going to build this in a way that it's open source, so that everyone can leverage all of the software, and they could adopt the same hardware. We're probably not going to give them our hardware, but they could go out and acquire this TurtleBot. It was actually an open source project. All the software that runs TurtleBot, even that stuff that Maddie showed, is open source. You can go up on the internet, download it, buy your own TurtleBot, and have it deliver donuts to Lise or anyone else you want on this as well. So this last slide that I have here is kind of next steps. I originally was going to build, like I told you, a bunch of classes, and I realized that wasn't going to work really well for this type of project. We're going to make it more of a community, and we have some examples of this. Like Keith works on a hydrophone project right now that's more of a community type thing. And they're building hydrophones all around the island to listen to all kinds of whale sound, Russian subs. Yeah, Keith, have you heard any Russian subs yet?
No, we're not allowed to listen to Russian
So,
You don't need a hydrophone with a Russian sub, right? You can just share them.
so we have Slack is a web-based communication platform. We use that a lot in the tech lab, so people can join that. I have basically a copy of this talk up there right now. There's a channel called ETA Barney, and you can read the project overview and basically learn everything that I talked to you about here. And that's a place where people can ask questions, saying, hey, Nat, I'm really interested in the planner part of what you talked about. How do I build a better planner than what you showed me in that screen? I can say, okay, here's the piece. Here's the APIs for PyRoboSim or any other simulator you want to use. You know, here's where you can start. So our goal is to get a V1. I kind of would like to have a V1 by this time next year, at least have the hardware assembled and doing a primitive tour of the tech lab. So you could walk in there, see a first version of Barney, and say, I want to take a tour. And it's going to take you around and to all the stations. Won't have any arms, won't do any 3D printing or laser cutting, but it will at least be able to give you a tour. And hopefully, I want to actually integrate it with a large language model. You can ask it questions and hopefully get reasonable answers back as well. That sounds like a big reach, but like I said, there are robots that are out there right now that are pretty close to doing this already. Like Connors is pretty close to doing that as well. Okay, that is the end of my talk. Thank you for joining.
So it'd be pretty straightforward to build a robot with a camera, with a live feed that would travel through a building under construction, and you could tell the robot pan up, pan right, pan left, and you as the operator remotely could.
Oh, I want to do that autonomously. So if it has a camera, then it's able to actually detect objects and do avoidance. So when it's going through that construction site, there may be a person that walks right in front of it, or someone left a pile of wood right in front of it, and it's got to figure out, okay, how do I navigate around that pile of wood, or how do I not hit that person that's
Which is not
standing?
its core mission, though. Its core mission would be to tell the operator the status of the construction.
Ah,
That's
okay.
what
Oh, you have a scenario. Yes. Yes, absolutely.
I'm an architect looking at the building under construction, and I'm not on site.
Yeah. Yeah. Yeah.
Oh, okay.
Yeah, there are drones that are doing that as well. And we had a series of drone classes. We don't have any new drone classes coming up, do we, Keith? No. Mark or someone else? Okay. That he could do Ray's scenario right there within a construction site and go through it and tell them the status of construction. Oh, I see. Oh, I see. Oh, yes. See, you see that scenario that he talked about? This is a drone that, suppose there's a building that's on fire or flooding or electrical problems. They'll fly a drone through it and see if it can diagnose or at least find them where the hot spots are or where the problems, without endangering a fireman or someone else. Yeah, that's an interesting scenario. I haven't seen a lot of that usage with fire departments and whatnot, but it totally makes sense. Police, I've seen. Police are starting to use it to monitor and to go into sites where there are an armed person and they don't want someone shot. But yeah, that is strong. And all the technology for what you talked about, Ray, is available. I mean, in some ways, even these guys have some of that technology in a primitive form, but it's there. And we got it to walk around the tech lab. And I used everything we talked about. I wrote that program, the PyRoboSim. I could use the ROS2 PyRoboSim and run that code on that physical robot and physically get it to walk around the tech lab without changing a line of code, from moving it from the GUI simulator to the actual physical robot. Yeah. Give a spider give a tour? I think that's too low of a bar. First of all, you know how long those last on battery, and there's no way to get it to dock itself. We've got to get that. No one will charge the thing long enough if you don't solve the docking problem. Yeah. There's actually packages that do this, and well, you've got to give it a model, right? And it needs to understand, like in the Speedway scenario, it knows the layout of Texas. So you say, okay, I want you to get from the Welch building to the Bill Gates computer science building. It says, okay, I'm here at the Welch building, there's the Bill Gates building, and then it's gonna try to walk and go through Speedway. And it's gotta say, okay, there's gonna be people in my way, there's gonna be scooters, there's gonna be e-bikes, and it's gonna try to navigate its way. There's software that knows how to take the input from cameras, recognize things, and avoid them as well. Correct. Actually, not a replacement, it's an addition. You still need the plan. You need the plan to how to get to Welch to Gates. Correct. And so it does, so the plan is the high-level plan. It says, I know how to get there, and then it's running what they call the object detection avoidance all the way through. So it realized, well, this is the way I want to go. There's a person there. Now I have to set a new waypoint. And it sets it there, and then it gets back on plan. So no, no, it does not. Correct. Yeah. Very similar to gazebo. Like gazebo on its own doesn't even know physics. You have to hook up Majuko, which is a physics engine, so that it actually knows about weight and everything else. Yeah. Sorry. Doug understands this. I'm not sure anyone else with it as well. Yes. So you need both of those, Doug. You need both that package for avoidance and detection as well as the high-level planner. Oh, no, that's the object detection and avoidance. I thought you meant the learning one. Well, if you do the detection avoidance, that scenario you talk about, you can solve. The more interesting thing is the learning part is, suppose someone comes in and says, puts in down a new device, and someone explains to the robot, this is what it is. It should be able to figure out where that is now, and it keeps record saying, oh, there's a new F1 Ultra, which is in there right now. I know what it does now. I know how to get there. I know where it is on my map. If someone asks me, show me the F1 Ultra, I'll be able to navigate. There it's learning something. It says, oh, I know something new about it as well. Yeah. Yes. Correct. Correct. Yes. Yes. So this platform, what? So it detected where something was blocking its way. Its software said, this route that I planned doesn't work. I need another route. So basically, think about it. It puts in the map saying, there's a block here. I can't go there. Give me another route. And so it will find the next best route.
It's like Google Maps, right?
Yeah, it's like Google Maps. Yeah, Doug calls that learning. I just call that renavigating.
That is sort of the difference between Waymo and Tesla. Waymo has the high resolution map that it's using. Tesla has no map.
Yes.
It's all, it's doing intuitive,
Yes.
recognizing this is the road. If the road changes from one day to the next, it adapts instantly, right? So we don't have that capability for this environment.
Right. Well, this Pi Robo Sim doesn't do, I mean, you have to add object detection, avoidance, and learning to it. It's just kind of a simulator platform, which I know so many platforms here, you go, whatnot. But those are pieces you would add to Pi Robo Sim. Oh, what they fed was they fed another visualizer, RViz, in it as well, which is, that actually comes with ROS, to tell you the truth. But it's it doesn't know physics, it doesn't know a lot of things. But for 2D planning, it's probably good enough. For robotic arms, it's not. Correct. And if it does change, with the LiDAR, it should be able to figure it out. You're always having that running. See, she ran it once in her demo, but there's nothing that keeps you running that always, right? And so that the building can be literally shifting around in its layout, and it'll say, okay, the tech lab suddenly, rather than an L, it's a long corridor, and it will figure that out.
What I don't understand is that basically the hand waving that you accused her of doing was basically the labeling, right?
Yes.
So how do you dynamically label those changes?
Yes.
Even if you have LiDAR running the whole time.
You are absolutely right, because suppose he changes office or there's something put in the way of his office and whatnot. Yes. So it's got to actually learn to say, okay, where's Mervin's office? Where it is, and someone can provide that as input. But you're right, it's going to have to change its original map to say, wow, I can no longer get to Mervin's office in the way I did in the past. Yeah, TotalBot 4. So ClearPath is the name of the company. They actually sell you TurtleBot 4s, right? That you can use that thing that Maddie has. Maddie worked for ClearPath that you saw in the video. Well, great question. I was actually going to build it from scratch up, but the more I look at it, that TurtleBot 4 costs $2,200. Yeah, I thought so too. Whenever someone says that much money, I can build that for cheaper than that. These things cost $50 for crying out loud. Yeah, it has a little better and it has LiDAR and whatnot, which is a little more expensive than anything on those. But still, $2,200 seems like a lot of money. Oh, how anyone would buy this TurtleBot 4? Oh. I, I'm getting the barn to buy it. So F1 Ultra or any of these others, what did we spend on those? Okay, you guys probably want to leave. These are all Tech Lab guys talking now. Thank you for coming, Lisa. You were my only customers for this as well. My wife is tired of talking to me. I'm glad you invited Lisa Ray, or would it me just talking to these three guys? I do. I'd go with Ray and go get a burger and a beer. Okay, we are done. What's up? Yeah. Oh, we could definitely do that. That's why I haven't committed this hardware. We may say, Nat, $2,200 is too much. Then we'll just scale it way down. I have robot platforms like that, not as capable as Turtlebot 4, that are like $500. Doug and I have been bouncing these around. And there's always the spider, too, we could use. So that's how. Oh, you can get a used Roomba, the previous Turtlebot 3 for like and just below $1,000, like the brand new. You know how much a brand new Roomba costs? Yeah, yeah, that's a lot. And you know how they're selling the new one, Keith? So the old one, it didn't have a lot of intelligence. It would just bump into things, bump into something, say, oh, can't go there. Go there, bump into your, oh, can't go there. The new one has LiDAR on it, and it can actually not bump into things. Yes. And it goes to its own charging base, too. It's a good question, though, Keith. It's what I'm struggling with first version of the hardware, what I can get Barn to pay for. This Turtlebot 4 would be nice. It's a nice platform, but it's expensive. Yeah, I didn't start this project with that goal, but Kate came in and said, Nat, that's now your goal. I don't want to do this anymore if you can get a robot to do it. Oh, good question. Whether it runs local or remote? Ooh, I don't know the answer to that one, to tell you the truth. There are some things that are, yeah. ROS will run on the Turtlebot, because think of that's the thing that actually talks to the actual hardware, the rotors that turn the wheels, the LiDAR, and it gathers data and sends it. Now, a large language model, that's ChatGPT, which runs in the cloud today. It doesn't even run on your laptop. That's not gonna, that's too big. Although Doug has found large language models that run locally on your machine. They require some resources. Yes. Yes. Makes your life easier.
Practical commercial scenario, you may be far away someplace, right?
Military.
Yeah. Right.
I'm not going down that road, but yeah, there are scenarios where you lose it. But for most of ours, assuming you have an internet connectivity, this place probably would come to a screaming halt if you turned off network.
Is Ukraine doing anything interesting with drones and software? And
oh yeah. Oh yeah. So you could do either one. Answer to your question is, it depends on what kind of robot you get, how much resources it has locally. It depends on what you want the robot to be autonomous and completely separate. Well, that's going to force you down a certain path. It means you might have to build more resources in your robot than if something that just talks to the internet. So it's interesting. I went up to, I think this was ChatGPT or Gemini, and there's a definition language for a high-width language planner. Remember how it got from like the laser cutter down over to the classroom? You can walk up to a LLM and say, generate PDDL, which is the definition language, for a plan to make my cup of coffee. So remember that scenario I told you where it arrives at your front door, right? And it doesn't know anything about the layout, but it's doing high-level planning, saying you need to find the kitchen. If you're going to add milk, you need to find the refrigerator. You need to open the refrigerator. You need to find the cups. You need water. You need to figure out how to make coffee with whatever coffee maker you find in there as well.
What value is that?
No, it's a high-level plan, and you can keep drilling down on it. Oh, I found the coffee maker. It's an espresso 460. It queries the internet. How do I make coffee with an espresso 450? You can see how you start. This is a computer science where you keep shrinking down things to smaller problems. you can see once it identifies the coffee maker, it can query a large language maker and say, how do I make coffee with this model coffee maker? They are, and they're very programmed and very fixed scenario. Yeah, they know. Yeah, they know exactly where the part is. They know how heavy it is. It's almost like they're pre-programmed to know how much weight they have to lift. So those are very programmed. To build a generic arm that can go into any house, reach up, grab a wine glass, bring it down, pour wine in it, we're not there. We're not there. There are people that can do it, but it takes literally to do that one thing that you do in 5 minutes, it takes it 50 minutes to do it. So, and it may still crush the glass or drop the glass. Yeah, yeah. Okay, thank you.